Woohoo! Welcome back. Today we're going to be working with Square Bear to get the answers to the Chapter 0 practice test. Remember, when you take the practice test, you can use all of your notes. It's open book, but when you take the actual test, it's going to be closed book, closed notes. But this practice test should help you prepare. So let's go ahead and get started. The first problem is worth 15 points out of 50. So suppose I want to sell apples at the market. I bought a table for $18.77 and it costs me 89 cents to buy each apple from the farmer. I decide to sell each apple for $1.05. So a couple things we can talk about. Anytime I say to buy each apple, that's going to tell me something interesting. And it's slightly different from, pardon me, Square Bear, it's slightly different from the 1877. Oh, that's a very light blue. Let me make that a little darker. So the 1877 here doesn't say for each apple. It just says, I bought a table, it cost $18.77. But these other two costs, pardon me, the cost that's 89 cents and then the price for each apple, $1.05, this is going to be each apple. So these are going to be slightly different numbers. Okay, let's get into it. If X, in part A, if X represents the number of apples I sell, write an expression for my total cost. So I will remind you that total cost is equal to variable cost plus fixed cost. And you can reverse that order if you prefer. So in this case, I'm going to use C, and those of you who have looked ahead, you're going to see that eventually we're going to call it C of X. So if you'd rather call it C of X, that's fine. I've got a variable cost and a fixed cost. Now the fixed cost is going to be the costs that I pay once, and then I'm done. Or it could be I pay once per season, or I pay once per whatever the length of time is. In this problem, it's a very simple problem. So I haven't really, done anything really exciting or interesting like worrying about rent or taxes, but I did buy a table. I bought that once, and that's going to count as my fixed cost in this case. Obviously, in a real-world situation, there would be many other costs. This problem is simplified so that it is easier to work with the models, just to get practice. Now, for the variable cost, those are the costs that change depending on how many apples I decide to sell. And for variable cost of the apples, I have to look into how much does each apple cost me. And so, let me see if I've got another color here that I can distinguish with. Let me use the purple as a second line there. Each apple, that's the cost of each apple, so that's going to be my variable cost right there. And then as long as I've done that, let me go ahead and do fixed costs. I'll underline that. So the fixed cost was the $18.77. The variable cost is each apple is 0.89. Now, the last part is to know that variable cost needs to be variable. If I just have a number here, a constant, it's not going to change. So I know that I need a variable, and I also know that X represents the number of apples. And since each apple is 89 cents, I'm going to take 89 cents times the number of apples, and that'll give me how much I'm going to spend to get the apples so that I can sell them. So that's my total cost function, except you guys don't know the word function yet, but that's my total cost equation. Then in part B, if X represents the number of apples I sell, write an expression for my revenue. Okay, so in this case, we have to remember that revenue is simply price times output. And in this case, our output is simply X, and then we have to go up and find the price. So when I say that I'm selling each apple for $1.05, oop, you know what? It dawns on me, pardon me for just a second. Let me underline this because I didn't quite underline the whole cost. There we go. So if I sell each apple for $1.05, that's my price. That is the price that I charge other people. And so I get 1.05x. Revenue is slightly easier than cost as long as you can identify what the price is. It's pretty straightforward in this model. Okay, then we move on to part C. If X represents the number of apples I sell, so same setup, write an expression for my profit. So the trick about profit is to remember that profit is revenue, which is the money that comes in, minus cost, which is the money that goes out, right? Revenue is the money in, cost is the money out. And so I take my two equations here and I write out, let's see, it's 1.05x minus, and then I've got my cost, 0.89x plus 1877. Now, if I leave it like this, I've got a mistake. And the mistake is that I have to subtract the whole cost equation. So here, when I do a minus there, that minus is only going to see the first term. So what I want to do is put cost in parentheses. And then that allows me to see, oh, I've got 1.05x minus 0.89x minus 18.77. And the tip off here is that whenever you look at profit, you should be subtracting your fixed costs, right? Whatever your fixed costs are, they should not be adding to your profit. They should be subtracting from it. So if you've done this correctly, fixed costs should have a minus in front of it. And I simply need to, except that I've totally run out of space. So let me see if I can get real squishy with it. I need to come up with 1.05x minus 0.89x, which you can go ahead and use your trusty calculator. You could do it in your head. I would recommend probably a calculator for the test because, you know, when you're taking a test, even if you feel pretty confident about something, the nervousness can make a lot of people make more mistakes. So I would double check with the calculator at the very least. But in this case, I'm going to go ahead and subtract. I think I can get this one. And I think I get 0.16x minus 18.77. Sorry, it got so squishy down there. So that's our answer for that one. Woohoo! First page done. Woohoo! Okay, so now I'm going to go ahead and move on to dun dun dun. Uh-oh, do I have two that are, no, there we go. How many apples do I need to sell to make $100? Okay, so in this case, when I use the phrase make, oh shoot, I should have had that in green. Ooh, I wish I hadn't already used my green. I'll use a different green. Hopefully it's not too confusing. When I say to make $100, I mean that that's the profit. And this can be confusing. In this setting, I mean profit. There are going to be settings in business where what you make is your revenue as opposed to your profit. So it's important to always check in. Like, did you mean revenue or did you mean profit? Do you mean the total amount you're going to bring in or do you mean just the amount you can keep? In this case, it's I want to keep it. So I want to set my profit equation equal to 100, and it's helpful that I have the profit equation right over here from the previous page. I just have to copy it down. So it is 0.16x minus 18.77, and I'm going to set that equal to $100. Now, some interesting things happen, and I'm always going to encourage you to consider the intermediate steps not as stumbling blocks, but as a place to learn something. Because the really great thing about business models and economics models is that the in-between steps, like this one, where we're not done yet, but this is interesting. So if I want to make a profit of $100, and I'm going to have to buy a table, and that table costs me $18.77, then when I'm selling my apples, I need to make 100 plus the cost of the table. So this is the total revenue I need to take in to make $100 profit. So that's kind of interesting. You can see, you can learn things, glean things from the intermediate steps. Okay, so what's the next step? The next step is I've got 0.16 times x. So to isolate x, I'm going to divide by 0.16. And then that I cannot do in my head. I would love to be able to, but I'm going to have to go ahead and use my handy dandy calculator. 118.77 divided by 0.16, because now what is 0.16? 16 cents is how much profit you make off of each apple, which we don't have a term for yet, but later on in the class, we're going to call that the marginal profit. That's the extra little bit of profit we get from selling each additional unit, in this case, each apple. So I'm going to divide that by my marginal profit, and I'm going to see that I'm going to have to sell a lot of apples. Oh my goodness, so many apples. And so here, my x, I'm going to move this over here so I can write. My x equals $742.31. Oh, sorry, it's not dollars. What am I saying? 742.3125, and I think it stops there. Apples. Now the question is how do we round? And then it says use your answer from part C, which we did. There's part C. This is let's see, this is part C right here. Part C. That's part C right there. And round to the nearest apple. So in other words, I'm telling you, don't worry too much about how to round. I'm just going to say just round with the standard rounding rules. So I'm going to put in my wiggly equals saying, okay, I'm rounding. Everyone stand back. I want to round to the nearest apple, so that's going to be this digit. So I go to this digit, and I see that this digit right here tells me that I'm going to round down. So I'm going to say it's approximately 742 apples. Now, having said that, if I sell 742 apples, pardon me, if I sell 742 apples, will I make $100? And the answer is no, I need to sell a little bit more than that. So I'm going to earn a little bit less than 100. So if I really wanted to at least make $100, I would have to round up in this particular case. So, but the answer was nearest apple. So that's it. We're done. Woohoo, yay! Okay, so we're at about 14 minutes, so I'm going to go ahead and let's see if we can start another problem. See how far we can get in the second problem. I will probably have to break this into 2 videos, but let's see. Okay, so this is a completely different problem. Number 2. I have $8,000 to invest, and I want to choose between one investment at 4.75% and a second investment at 12.5%. And hopefully from class, from the lectures, you've understood that you don't want to throw everything in at 12.5, although it is very tempting because 12.5 is a really high rate of return. And so that means there's probably a lot of risk involved. So you want to balance your portfolio. So the goal is I'm going to balance this, see how much I'm going to put in each. So right now, oh, sorry about that. Hello. There's a little fly here helping me with the problems. Decided that he wanted to get a closer look. So I'm going to go ahead and set up an expression that tells me if I invest X dollars in the first investment, it's 4.75%, how much interest will I accrue in 6 years from the two investments combined? So there are a couple things going on in this problem. The first one is that we have a very basic formula, and since you aren't told about any compounding, we're assuming this is simple interest. And if you haven't studied a lot of interest formulas, then you may be saying, what is compounding? And we'll get to that later on in the class. But for right now, we've got something called simple interest. So there's no interest on top of interest. It's just straight up interest. So it makes the problem a little bit easier. I am going to go ahead and use a chart. I'm going to set up a chart to solve this problem. You do not have to. I'm going to start with a single row that's going to give me my descriptions for each of the columns, and a single column where I'm going to do my headings as well. I'm going to use 2 rows for each of the investments, and then a bottom row for the total. So this is going to be the 4.75? Oof. What? Look over there. Is that a pterodactyl? Oh my goodness. How'd that get in? 4.75% investment. Ooh, squishy. And then the 12.5% investment. Then I'm going to put a happy face here because we love business, money, math, whatever you find that you can love it. Okay, now although I wrote I equals PRT, I am going to reverse this. I'm going to give myself a P column for principal. I'm going to give myself an R column for interest rate. I'm going to give myself a T column for time, and these are all going to be multiplied together, and then it's all going to be equal to I, the interest. So this is not going to give me the total amount I have. This is going to be just the interest I earn, and that's really going to be helpful because I want to find an expression for how much interest I will accrue, not the total amount, just the extra amount. So I am going to, it says I invest, in this case, I invest X dollars in the first investment at 4.75%. So that's going to go right here. So that's going to be my X. Okay, what is the interest? Well, 4.75 is the interest rate, but that's in the form of a percentage, and it's going to be a lot easier to work with as a decimal. So I'm going to write out the decimal. Remember, I slipped the digit twice. This is going to be 0.0475. How long is it going to be? It's going to be 6 years. And then if I want to find how much interest I would earn, I just multiply. So in this case, I've got X times 0.0475 times 6, and that whole thing is going to be, what was it? 0.0475 times 6 gives me 0.285x. And notice I'm going to write the coefficient in front of the x. Oh, sorry about the smeary. There we go. I'm going to write the coefficient in front of the x because that's just tradition. So, this one's a little dicey. I'm going to leave this for a second. And then for my total, I know I've got $8,000 to invest. And the interest rate, well, I've got 2 different interest rates, so I can't, this is not going to be helpful. It's 6 years. And am I going to know how much interest I'm going to earn? Well, I need to figure this out first, and then I'll be able to figure this. Okay, so now let's dive into the belly of the beast. Hopefully, before you're taking the test, you have read the book or heard the lectures or done some of the homework so that you're not coming into this for the very first time. But there's a little trick I'm going to use. Now, some folks feel comfortable with using a y here, bringing in two variables, and that's absolutely fine, but that's not the approach we took in this chapter. So if you want to use a y, that's great. You will get to the same result, except then you're going to have to convert. When I say write an expression for how much interest I will accrue in 6 years from these two investments, you will need to convert it into x's at the end. So instead of doing that, I'm going to go ahead and just use x from the beginning. So how much do I have to invest here? Well, if my total is 8,000 and I'm putting x into the first investment, then what's left is the total 8,000 minus whatever I invest in the first investment. So I've got 8,000 minus x. So if I put 1,000 in there, then this would be 7,000. If I put 2,000 here, then this would only be 6,000, and so on. I'm going to convert my interest rate from a percentage into a decimal. 12.5% is really high. So unless you're a bank and you've offered someone a credit card, this is an investment that's either really amazing or really risky. So be really careful. This is 6 years. And now, unfortunately, this one's going to be a little bit uglier, but it's still going to be true. And we're just going to move slowly. I'm going to take my 8,000 minus x, which is my principal, and I'm going to multiply it times 0.125, and then I'm going to multiply that times 6. And so here I've got a couple of options. What I think I will probably do is I will go ahead and take these two numbers and multiply them. 0.125 times 6 gives me 0.75, and I will write it like this: 0.75 times 8,000 minus x, which might look a little goofy and like, why did you write it like that? Well, 0.75 is still effectively a coefficient. It's the coefficient of this factor which has the x in it. It's still a little messy, so I'm probably going to want to do some work on this. Now, normally, how would we get to this box? Well, the way we would get to this is, even though we're multiplying across, this interest comes from the first investment, this interest comes from the second investment. So what we want to do is, as we're moving down, we want to add these together. So that box is not going to be big enough. So I'm going to move down here. And I'm going to come over here. And I'm going to say, I'm going to take 0.285x, and I'm going to add it to 0.75 times 8,000 minus x. Like that. This is investment 1, this is investment 2. And then I realize if I'm going to combine, I really need to multiply through. So I'm going to go ahead and use the distributive property and multiply through there. I get 0.285x plus, and I've got 0.75 times 8,000, which is something you might be able to do in your head, right? 3/4 of 8,000 is 6,000. And then I'm going to subtract 0.75x, and this is a minus because of the minus there, right? The distributive property is going to preserve that sign since this is a plus right here. We're multiplying by a positive number, so the first 8,000 is positive, so 6,000 is positive, x has a minus sign in front of it, so this is negative. And then I can combine this and this. And for a moment, it's going to be a little bit uncomfortable because we're going to add these two together, or subtract them in this case, 0.285 minus 0.75, and then we realize, oh my goodness, it's negative. So I'm going to earn negative money, and the answer is no. The answer is you're going to start with a maximum of $6,000. What is $6,000 going to be? $6,000 is if you put all of the money in the second investment. So if you skip the first investment entirely, so X, the amount in the first investment, is 0. So if that's 0, you could make $6,000. Very high risk. But for every dollar you put into this 4.75%, as I'm recording this, still a pretty good rate of return, although interest rates are currently rising as I record this. So, it may not be great when you're watching this. It's hard to know what's going to happen in the future, but still pretty good. But for every dollar I put into this investment, I'm going to take away 46.5 cents from 6,000 total. So this gives me an expression. So if you were working with a client and they said, well, I'd like to put $1,000 into this account and 7,000 into this account, rather than working this all out, you'd have this expression and you could just say, oh, if I put $1,000 in here, this is what what's going to end up happening with your interest. This is how much interest you'll be earning. Okay, so woohoo! So this is the total interest after 6 years. And I think because we're we're at 26 minutes. So I'm going to go ahead and stop the video now. There will be a part 2 coming and we'll go over the rest of the problems on the practice test. So for Square Bear and for myself, Math On. Know that you're amazing. Make sure you take a break, go look at something green, get some fresh air or some sleep or a snack. Definitely hydrate. And I will see you in part 2. Part 2. Woohoo! Okay, Math On.